Hello everyone, welcome to Adam. So now we're going to solve this question, which is based on SFT and BMD, where we have been given that a cantilever beam has a fixed end at left side. So that is, this is the cantilever beam, which is a fixed, which has a fixed end at left side. It carries 3 points load, point loads at 300, 500, and 800 at distance of 0.5. So let's say this is a 300 point load. This is the 500 and this is the 800. Then the distances are given such as 0.8, 0.7 and 0.5. Draw the shear force and bending moment of the beam. So firstly we know that we need to draw the ability of the beam which is given. Then we will find the shear forces and then we will find the bending moments at every point for the following beam. So let us just name the points which is A, B, C, D. Let us name them. If you draw the ability of the following beam which we have, we can draw like something like this. We have A, B, C, D. At A we have reactions. Whenever there is a fixed support, you need to give 3 reactions, which one of them will be FAY, which is in one force in the vertical direction, FAX force in the horizontal direction, and a moment at A. So M moment at A. The unknown moment at A, which is not known, you need to find that. For now, we are assuming that it to be anti-clockwise. So at B we have a force of 300, at C we have a force of 500, and at D we have a force of 800. And the distance is nothing but 0.5. This is 0.2. This is 0.1. Yeah. So let us see how we can solve this. Firstly, we need to find the unknown reactions. So how we'll find it? We will just apply the equilibrium condition. So equilibrium conditions. So first will be summation of fx is 0. The second will be summation of fy is 0. And the third will be summation of movement at any point is 0. So if you apply the summation of fx is 0 condition, the fax will come out to be 0 here. Because there is no other force, and we have fax in the vertical direction. So first we have completed that fax is 0 because there is no other horizontal force. This is equation number 1 here. And from this second equilibrium condition, we have fay minus 300 minus 500 minus 800 as 0. So we will have fay as 1600, yeah, 1600 in the upward direction. And from the third condition, we will get the unknown moment. We have, let us calculate moment at point A and equate it to be 0. Moment at point A is 0, which is summation of moment at any point is 0. So you can apply this condition at A, B, C, D. But we are applying it at A because we need to find the unknown condition, unknown moment at A. You can apply anywhere. The unknown moment will come out to be same. Should come out to be same. We have 300 into 0.5 as the first movement in the clockwise direction. We are taking clockwise as positive, so that is why. So 500 into 0.7 plus 800 into 0.8 plus, so mx is in the anti-clockwise direction, so that is why we'll take it as a negative, minus mx. We are assuming it to be in the anti-clockwise, so mx comes out to be 300 into 0.5. If it is not like, if it comes out to be negative, then we know that the assumption is wrong and it is in the clockwise directions, but it will come out to be positive, so it will be in the anti-clockwise direction only. So 300 into 0.5 plus 500 into 0.7 plus 800 into 0.8. We have 1140 as our moment at point X. So yeah, we can just write the values here, which will be 1140. The fay, fx is 0, fay is nothing but 1600. yeah, we have found out the unknown forces or the reactions forces at point A. We can just draw the shear force diagram using calculating the shear forces at every point now. So we can calculate shear force just right of A. So just right of A, we have considering force on the left, we have 1600 as the shear force, and shear force just left of B, just left of B, we have 1600 only. Shear force just right of B, we have 1600 minus 300, which will be 1300. Similarly, shear force just left of C will be 1300 only, because there is no shear force between right of B and left of C. And so similarly, there is a right of C, it will become 1300 minus 500, which will be 800. And shear force just left of D will be 800, and shear force at D will become 800 minus the 800 which is there at D only, so it will become 0. So this is how you can like calculate for your shear forces at every point. We can just draw our diagram, which will be A, B, C, D. At A we have a shear force of 1600 at just right of A, and just left of B it is 1600, then it is dropping to 1300. Just left of C it is 13, it is dropping to 800, and just left of it is 8, it is dropping to 0. So this is how you can draw your shear force diagram. Talking about bending moment now. So for that we need to follow like the sign convention that whenever you are considering forces on the left, the clockwise movement will be positive and anti-clockwise movement will be positive. Negative. So yeah, bending moment for the left side, the clockwise movement is positive and anti-clockwise is negative. For the right side, clockwise is negative, anti-clockwise is positive. So yeah, we have a point at point A. We have a bending moment. Let us calculate just right of A, because there is a certain moment at A. And if we look at the left of A, because considering all the movements on the left of A, let us cross the wheel somewhere here, right of A. So bending moment, right of A, just right of A, and considering forces on the left side. So the movements on the left side. So we have only one movement, which is 1140 in the anti-clockwise. So anti-clockwise will be negative. So minus 1140. We have a bending moment at B. So bending moment at B, you can calculate either from the left side forces or on the right side forces. So we will calculate from the right side forces. We have 500 into 0.2 minus, because both of them are clockwise and on the right side. So right side clockwise is negative. So both of them are negative. 800 into 0.3. So 500 into 0.2 plus 800 into 0.3, 340. So it will be minus 340. And bending moment at C, considering force on the right, will be 800 into 0.1, which is 80, negative, because it is clockwise. And bending moment at D will become 0, because it will be an equilibrium condition. If you consider all the movement, it should come out to 0. Yeah. We have a bending moment. Let us draw the beam again. We have A, B, C, D. At A, we have a minus 1140. At B, we have a minus 340. At C, we have minus 80. And at D, we have 0. You can just draw the diagram such as this. This entire thing will look like something like a straight line. So this will be a straight line. This will again be a straight line, and this will again be a straight line. This is how you can draw your bending moment diagram. Because there is no utility between, so the connection will be of straight line and not a parabolic like variation of bending moment between any 2 points. So there will be a linear variation only. This is how you can solve this question. Thank you.